Today's lesson is about understanding locations on a graph. Your learning target says, I can describe what a point on a graph means in the context of the problem. On this slide, we see some babysitting information. On the x-axis, which is the bottom part of your graph, we see the time worked in hours. And on the y-axis, which is your side, our label says earnings in dollars. So we are comparing how much time was worked to how much money was made. It says the amount Sandy earns from babysitting is proportional to the number of hours she works. The graph represents this proportional relationship. Now you can look at a graph and know it's proportional if it follows two set criteria. Number one, is the line straight? If we look at this line, it's a nice straight line, so that's part of the criteria. The other part, does the line pass through the origin? If your line in your graph is both straight and passes through the origin, which is right here, it is proportional. So our lesson is understanding what a location on our graph means. So I have a location right here, 0, 0. That means on the x-axis we are on 0, and on the y-axis we are on 0. That's actually the origin right here, 0, 0, over 0, up 0. And I want to know what that represents in the context of this real-world problem. So the first 0 is how much time is worked. And the second 0 represents how much money was made. So we have 4, 0 hours worked. Sandy made no money. So I have a new point that we're going to try to understand in the context of the problem. So 614 means I go over to 6 and up to 45. That is this location right here. The 6 represents hours worked. The 45 represents money earned. So I will explain in words. For 6 hours of babysitting, Sandy earned $45. That is my explanation of what 645 represents in the context of this problem. I can also use my babysitting graph, which is proportional, to find the hourly rate that Sandy charges and write this as an ordered pair. So hourly rate, I want to know how much money does she make per 1 hour? Well, 1 hour is right here. And I can go up to my line, take a hard left, and go across. And it looks like she's making $7.50 per hour. To write that as an ordered pair, remember my x-axis information goes first. So for 1 hour of work, she makes $7.50. Sometimes I'm given just written information, and from that I have to create the graph based on a table of values. So it says Lena paid $18.96 for 3 pounds of coffee. And then it says, let X be the number of pounds of coffee and Y be the total cost of the coffee. We're going to make a table showing the price of 1, 2, 3, 4, and 5 pounds of coffee. So that's a lot of information. Let's break that down. X is the number of pounds. So X, number of pounds. And then it says, Y be the total cost. Y will be the total cost. And then it says we want the price of 1, 2, 3, 4, and 5 pounds of coffee. 1, 2, 3, 4, and 5 pounds of coffee. Well, I already know 3 pounds of coffee. That cost $18.96. And now I have an ordered pair. I could do a little bit of math magic here. If I want price per pound, I could find the unit rate. I could take that $18.96 and divide it by 3 pounds. And if I picked up my calculator and did that, I would end up with $6.32 per pound. So that just gave me another piece of information. $6.32 for every 1 pound of coffee. So that means 2 pounds of coffee is going to cost $12.64. I already know 3 pounds. So if I added another $6.32, I'd get 4 pounds of coffee. Cost $25.28. And if I added another $6.32 for 1 more pound, I would know that 5 pounds of coffee would cost $31.60. Notice all I was doing was I was adding my unit rate each time to get the new amount. So now that I have my data as ordered pairs, I can certainly draw in a graph for that. So I already have my title right here, buying coffee. I'm going to draw in my Y and my X-axis. I already know what the labels are from my table. My X-axis was pounds of coffee, and my Y-axis was how much it cost. And I had bought 1, 2, 3, 4, and 5 pounds of coffee. I'm going to cheat a little bit here because I skip counted by the same amount. I skip counted by my unit rate. So I'm just going to put in 1 pound of coffee, 2 pounds of coffee, 3 pounds of coffee, 4 pounds of coffee, which is 25.28, and 5 pounds of coffee, 31.60. Now I was able to do that because my intervals were all even, and so I could use my data right off the table. So 1 pound of coffee cost this, 2 pounds, 3 pounds, 4 pounds, 5 pounds. If I were to connect my dots, would I have a proportional graph? In other words, do I have a straight line that passes through the origin? And the answer to that is yes. So for example, even though 0, 0 was not part of my table, it would make sense that if I bought 0 pounds of coffee, it would cost $0. Now let's see if we can determine from the graph what our cost per pound is, our unit rate. So remember, we want cost per pound of coffee. 1 pound of coffee is right here. If I go up to 1 pound and then take a left from my line, I can. My ordered pair is 1 pound of coffee costs $6.32. Okay, grab a note card. They are up on my front Elmo cart. I want you to write, what is something you feel you understand about this lesson? And what is something you still have a question about? Make sure you put your name on the card and turn it into the period folder.